The last type of factorising we're going to show you is when you're factorising a trinomial. Now, a trinomial has three terms. That's the tri bit, tri meaning 3. If we've got an example like this, x squared plus 8x plus 15. Now this is slightly different to either the common factor or the difference of two squares. What we're basically looking for is two numbers which fit into brackets, exactly like the layout of difference of two squares, where we have the first terms multiplying to make x squared. So that's clearly going to be x and x. And the second two terms, these numeric terms here, multiplying to give me 15. But they also have to add to give me 8. Now what I'm basically going to look for, and this is a slightly different way of doing it, not the traditional way, I'm going to write down the coefficients. The coefficients are numbers in front of terms, or however many you've got in each term. So I've got 1x squared, I've got 8x, I've got 15. What I want to do is break that 8 up into 2 bits, plus 8 and plus 15. I'm going to write ratios which mean exactly the same in each bit. So what I want to do is break up that 8 so that this number here and this number here create the rest of two ratios, so that 1 to something is the same as something to 15. Now I can do that by saying it's going to be 3 and 5. And if it's not 3 and 5, the only other way I can do it is to reverse the numbers and do 5 and 3. Now, what I've got here is this simplified version, the simplest ratio I can using these numbers, 1 to 3. And I've got the simplified ratio here, 1 to 5. I started off with x squared, so this 1 is basically 1x, and so is this one, which I've got here in my first bracket and here in my second one. The only bits that are missing are the numbers 3 and 5. That means to say that 3 and 5 go in the gaps. Having factorised it, it's going to be x plus 3 times x plus 5. Let's square that off and do another example. Let's say we've got x squared plus 7x plus 6, let's say. So I've got 1 and 7 and 6. Right, what I want to do is split this 7 up into 2 bits, so that this ratio here on the left hand side, 1 to something, is the same as my right hand ratio, something 6. Now how can I split 7 up into 2 bits so that these two are the same? Well, the only way I can do it is to actually say it's 1 and 6, because 1 to 1 is the same ratio as 6 to 6. And if it's not, what I do is I change the numbers around. It's obvious that these 1 to 6 and 1 to 6 are the same. So I've got one bracket which says x plus 1 from here, 1x and 1, and the other bracket which says 1x and 6 I'll write as x plus 6, and that's me factorised x squared plus 7x plus 6. A couple more examples. Now you'll see the difference here. I've got x squared plus 3x minus 40. That means that I've got 1 here, I've got 3 here, and I've got minus 40. Now, that shouldn't be a problem if we know what we're going to do with it. I'm going to break the 3 up into 2 bits, but what I want to do is make these numbers together multiply to exactly the same as these numbers. It would have worked in the previous example, exactly the same, but I've got 1 times minus 40, which gives me minus 40. So these two numbers I'm breaking 3 up into also multiply to minus 40. Now if two numbers multiply to a negative, one must be negative. So that's like saying 1 take away the other gives you 3. Here are my two ratios, 1 to something and something to minus 40. Now, the only way to do it is 8 take away 5. Well, it's not the only way to do it. If it's not 8 and minus 5, it's going to be minus 5 and 8. So my brackets are from here, 1 and 8, which is 1x and 8. And the other bracket is from here, 1 and minus 5, which gives me x minus 5. This next example is a wee bit more tricky because what we've got is a number in front of the x squared term. 2x squared plus 9x plus 4. Now my coefficients, the numbers in front, are 2 and 9 and 4. So I've got to split my 9 up into 2 bits. But what I need to remember is that the 2 and the 4 multiply to give me 8. So these two numbers here multiply to give me 8 as well. So my ratios are going to be 2 to something and something to 4. Now there's only one pair of numbers that multiply to give me 8 and add to give me 9. That's 1 and 8. And if it's not 1 and 8, it must be 8 and 1. Now I've got the ratios 2 to 1, which I can't simplify. I've got the ratio 2 to 8. Now I can simplify that. The simplified version is over here. So these are the ones I use. I use the most simplified versions. My ratios are 2 to 1 and 1 to 4, so my brackets are 2 and 1. That's 2x and 1. And 1x, or just x, and 4. Just take a few seconds to make sure you understand this. It's always the simplified versions. Now, if this was able to be simplified, if I could simplify it any further, I could do. If I could simplify this, I would do. We absolutely have to take the simplified versions of each one to get the right answers in the brackets. Right, pause the video now and have a go at these 5 questions. Be careful with the signs in question 3. Think about what they have to be. And be careful with the ratios in question 5. Make sure you simplify them once you've worked out what the missing numbers are. Pause the video now, have a go at these questions. Right, here are the answers. What you should have. It doesn't matter which way around the brackets goes. You could put the first bracket second and the second bracket first, as long as you've got the numbers matching with the signs. That is the most important thing. You can't just change the numbers with the signs, it does matter. So the first one is x plus 6 times x plus 2. The second one is also plus 6, but the second bracket, or the other bracket, is x minus 5. With question 3, this is the one I told you to be careful with the signs. both the numbers in the brackets are negatives, but a negative times a negative gives you a positive answer. That's why that's plus 21 at the end. Here you have 2x plus 5 times x plus 1, so the ratio should have been 2 and 5, or 2 to 5 and 1 to 1. And the last question, this is a bit more tricky. You should have 2x plus 3 and 3x plus 2. Now the reason is, when you've got 6 and 13 and 6, you have to break that 13 up into 2 bits, which multiply to give you 6 times 6, which is 36. So you've got a ratio of 6 to something and a ratio of something to 6, or the other way round. Now the numbers are 4 and 9, and if they're not 4 and 9, sorry, they must be 9 and 4. The 6 always goes on the outside. Whatever you start with here and here, they must be the start and end of the first and the second ratios. Now, 6 and 4 you can simplify down to 3 to 2. So that's one of the brackets. 6 to 9 you can simplify. Sorry, I'll say again. 6 to 4 you can simplify to 3 to 2. Divide both of them by 2. 6 to 9 you can simplify to 2 to 3. So the bracket that comes from here is 3 and 2, or 3x plus 2. The bracket that comes from here is 2x plus 3. Now that takes a wee bit of getting used to. So just pause the video again. We've come to the end of the video for factorising. So just take your time and have a look through these. If you need to check with FOIL again, go through your answers, use FOIL, multiply out the brackets and check that you're correct.